Hello, and welcome back to Fun with Statistics with Dr. David Bugg. Today we're going to examine nonparametric measures of correlation. We've been examining nonparametric measures of hypothesis testing with the chi-square test. And today we're going to apply nonparametric tests to the issue of correlation. There are several nonparametric measures of correlation that we can use. And depending on what dependent variable we are using and what level of measurement it exists at, depends on what nonparametric measures of correlation we should use. To refresh, nonparametric measures are dealing with dependent variables that are measured at the nominal or ordinal level. And so when we have a correlation where the dependent variable is nominal or ordinal level measured, we use nonparametric measures of correlation. If you look at PowerPoint 12 for nonparametric measures of correlation, our first nonparametric measure is called gamma. Gamma is for use in situations where we have ordinal level data and we have random sampling. We can correlate then two variables, an independent and dependent variable, with ordinal level data with the gamma statistic. The gamma statistic tests the statistical significance of this correlation using a chi-square test. Other measures of correlation with nonparametric tests include the phi coefficient, which is a correlation coefficient for nominal level data. The phi coefficient is used when an independent and dependent variable both have two categories and create a 2x2 table. In most cases, both the independent and dependent variable are measured at the nominal level, and random sampling is available. We measure the phi coefficient statistical significance with chi-square. Another measure of correlation with nonparametric measures is known as the contingency coefficient. The contingency coefficient is for use with nominal level data with larger than 2x2 tables, or in other words, either the independent or dependent variable has more than 3 categories. When we use the contingency coefficient, we measure its statistical significance also with the chi-square statistic. Requirements for using the contingency coefficient are nominal level data for the dependent variable and any level of measurement for the independent variable. But again, one of the variables, either the independent or dependent, has more than 2 categories. One of the things that we have to be aware of when we're dealing with correlation is the issue of elaboration. Elaboration is defined as the process of controlling a 2-variable cross-tabulation for additional variables. So for example, if we're examining the independent variable gender, a common variable used in our class, on a dependent variable, we may think about other independent variables that may also affect the dependent variable, such as race, socioeconomic class, level of education, and so on. Elaboration allows for us to examine 2 independent variables and their effect on the dependent variable. Elaboration then, after we control for a second independent variable in a cross-tabulation, could lead us to see changes in the nature of the relationship between the first variable and the second variable. One common example of this is called a spurious relationship. A spurious relationship is defined as a non-causal relationship between two variables that exists only because of the common influence of a third variable. The spurious relationship disappears if the third variable is held constant. We've examined this already in our class when we examined the relationship between heat and homicide. Heat does not correlate to homicide once we control for another variable, social contact. When we control for social contact, the influence of heat on homicide disappears. And so this is what we mean by a spurious relationship. Another form of elaboration is called a conditional relationship. Conditional relationship is when the effect of the independent variable on the dependent variable changes based upon the introduction of a third variable, and the strength of the relationship between the independent variable x and the dependent variable y changes. Elaboration outcomes come in a variety of different ways. When controlling for a third variable between the independent and dependent variables, the relationship can remain unchanged, strengthen, weaken, disappear altogether, or change direction entirely. And so we can start to control for some of the complex relationships that we see in the real world through the process of elaboration. And this can be done even with a weak test, such as nonparametric tests of correlation.